Okay, we're going to do linear patterns today, and I use this example of a plumber who has a call-out fee and call-out fee of $20 plus $40 per hour. And I want to talk about what does linear mean? What does it mean to have a linear pattern? Okay, so a couple questions first. Okay, so if we want to find the cost of the plumber after a certain number of hours, 0 hours means he just comes out and he didn't do any work, just a call-out fee. 1 hour he worked for an hour, 2 hours, etc. Okay, well, after 0 hours of work, he's not going to charge you the $40 per hour, just the call-out fee. So that's just going to be $20. And after 1 hour work, well, he's going to charge you that $40 per hour. It's $40 times that 1 hour plus the call-out fee. So 1 hour is going to give me $60. And so on and so forth. So for 2 hours, gives me $100. And for 3 hours, I get $140. Alright? So now what we're going to do is we're going to look at these values, comparing the number of hours and the cost, number of hours of cost, number of hours and cost, and we're going to plot them on a graph where the horizontal axis is hours and the vertical axis will be my cost in dollars. Alright, so I've got my axes labeled and I've got them in equal intervals and it's all ready to go. So let's plot this first one here. And I'm going to write it as an ordered pair. So an ordered pair means number of hours and cost. So an ordered pair looks like this. After 0 hours, it's $20. I don't put any units in there. And we'll do the same for each set of ordered pair. Okay, so what I'll do with each ordered pair is I'll put it on the graph, and I'm just going to put each ordered pair as a little cross on the graph. So we'll start with 0.20. That's the call-out fee for no work done, just coming out and charging you $20. So they're called linear patterns because the points form a straight line. Now in this example, like I said earlier, we're not going to draw a line through this just yet because the plumber may not charge for a fraction of an hour. He may not charge for 1.3 hours or 3.2 hours, etc. So next question. Okay, so write the rule connecting the cost in hours. In math, this word right here, it means write the equation connecting these two variables. Okay, so when we have something like this, it's kind of confusing, but the cost depends on the number of hours. So the cost is what we call the dependent variable. Cost depends on hours. So when we write the rule, this dependent variable, whatever is on the not y-axis because it's C, but whatever's on the vertical axis is the dependent variable. Cost equals $40 times every hour plus the $20 call-out fee. Okay, so our equation is cost equals 40 times H plus 20, where 40 represents variable cost and 20 represents fixed cost. And once we have the equation, we can ask any questions. Okay, so the first question is finding the cost after a certain number of hours, and once I've got my formula, I can just substitute H for 17 into here simply to find the cost. Pretty big job if it's 17 hours worth of plumbing. Okay, maybe some toilets exploded in your house, but let's see what we get. So I get a cost of $700. Pretty big bill. What if the question's the other way around? What if I give you the cost and you have to find the number of hours? Alright, so let's find the number of hours if the cost was 460. Well, what I do is, instead of substituting in for H, I just substitute 460 in for the cost and solve for H. So we set it up like that. Now I'm going to use the properties of solving equations, not like this was substitution, but solving equations to get H, which is the number of hours. When I take that 20 and subtract it to the other side, I get 440, and my last step will be to divide by the coefficient, which is 40. and I get a job that took 11 hours. Alright? Using the formula that you're going to have to get on your own. Okay? Next. So suppose I leave all the words out of it. Suppose I don't have anything about a plumber or a graph, and instead what I do is I just give you the set of these ordered pairs. Okay, suppose I give you all of the x-coordinates, like 0, 1, 2, 3. I don't have 0, but 1, 2, 3. And I give you all of the y-coordinates, which in this example were the costs down here. And I want you to write the rule. But remember what I said about the rule, how it's usually the dependent variable over there, which is, in this case, the cost. And if it's just a normal graph with x and y, it's always going to be the y, because that's the vertical axis there. So when I do write my rule, if it's just x, y, it's always going to be y equals something. Okay? Now, I need to get two things here. I need to get what the variable cost is and what the fixed cost. But this one has nothing to do with costs. So what I want to do is I want to look at the y values, just like I did here, 20, 60, 100, 140, and I want to see how much they're going up or down by. 20, 60, 140 are all going up by 40. Alright? So here, what I look for is how much are those going up by. So the y values are going up by 7. That is also like my variable cost, which later we will see is also like the gradient of the line, but we'll get to that later. So whatever that common difference is, that is going to be our coefficient for the x term. If it goes up by 7, it's 7x. If it goes up by 3, it's 3x. If it's going down by 2, it'd be minus 2x. And then finally, this end bit right here is like the fixed cost, and the fixed cost is the value of that 0 term. It's the value when x equals 0. So once you find out that x value right there, that is the last term of your equation. Now the value of that x term is 2. You can get that a number of ways. If it's going up by 7, that means to go backwards, we're going to subtract 7. So these two numbers are the key with finding out the equation. And if it doesn't have anything to do with cost, then what this is going to be is, now once we have this rule, we can answer questions such as we did here. We can find y when we're given values of x, and we can find x when we're given values of y. Okay, more on that later.